So on the exponent page, up at the top, the first thing it starts with is the rules for exponents. So you have the product rule, the power rule, the quotient rule, what happens when you have negative exponents, and what to do when you have a zero exponent. So this is like a little cheat sheet up at the top, and then down here is some problems, all right? For the product rule, when you're multiplying two exponents that have the same base, notice this is an x and this is an x, that base is going to stay the same, x, okay? Because in a bigger problem, you might have multiple bases, like you might have x, y, and z. So the x's will go together, the y's will go together, and so on, all right? But if you have the same base, keep that base, and then you're going to take the exponents and you're going to do what with them? Add them. So you're going to say a plus b. Next box is the power rule, or you may have heard it referred to as the power to a power. It's kind of, they used interchangeably. So the parentheses are usually what tips you off, right? If you see parentheses in an exponent problem, you're probably going to be using the power rule. The base stays the same. Then you take the exponents and you do what with them? Multiply them. So you'd have a times b. The next box says the quotient rule. The quotient means to divide, right? And the product means to multiply. So what if we add the exponents here, what do you think we're going to do with them here? Subtract them. So the base is going to stay the same. Then you're going to take the exponents and you're going to subtract. Okay? Depending on where you move it to. So we're moving it up to the numerator, right? If you're moving it down to the denominator, it's the order is going to matter. So we moved this one up to the numerator, so we said a minus b, but if we moved this one down to the denominator, we'd say b minus a. The reason I'm pointing that out is because with subtraction, order matters, right? 3 minus 7 is not the same as 7 minus 3. Okay, you get two different answers. So order matters with subtraction and division, right? The next box, negative exponents. You cannot have your final answer have an exponent that's negative. So we're going to change it into a fraction just like we did yesterday by writing it over 1. And then we're going to move whatever part of the factor to the opposite place. So if it's in the numerator, we're going to move it to the denominator. If it's in the denominator, we're going to move it to the numerator. So x to the negative a moves to the denominator, becomes x to the positive a, and then we need a placeholder in the numerator. Can't just leave it blank, right? The last box, anything to the 0 power is? Not 0. 1. 1. Even a million to the 0 power is 1. Anything that has an exponent is always the number 1. All right, let's try some problems. Some of them only involve one rule, but some of the problems could combine multiple rules within the same problem. That make sense? You could have product rule and quotient rule. You could have power rule and a negative exponent. So just be aware that it's not always just one rule. It's usually multiple. Okay? Box number 5 says negative 5x to the 3rd times 4x to the 4th. So we're going to use that product rule where we add the exponents as long as the bases are the same. Both bases are x, so we add the 3 and the 4 to get 7. The coefficients are negative 5 and 4, so we just multiply them to get negative 20. So the answer is negative 20x to the 7th. Some of these are only one step. Some of them are like 2, maybe 3. They're a lot shorter than what we looked at yesterday. Okay, box number 6. I see a set of parentheses, so it's probably going to be what rule? Power rule, right? Remember, look for the parentheses, which means you're going to multiply those exponents. That everything that's in the parentheses needs to go to that power of 2, including that coefficient -2. So you have to take -2 to the second power. Anybody know what -2 to the second power is? 4, right? Because -2 times -2 is +4. Then we've got a base of m. We multiply the exponents 3 and 2, and we get 6th power. Then we've got the base of n. It's to the power of 1. If it helps you, write the 1. And then multiply the 1 times 2, which is 2. Rewrite that second factor, 7mn to the 4th. And then we just have one more step to simplify, so let's multiply the coefficients first. 4 times 7 is 28. We have a base of m here and a base of m here. We'll put a power of 1 if that helps you. Add the 6 and the 1 to get 7. Then we've got base of n, so 2 plus 4 is 6. Any questions on box number 6? All right. Box number 7. That 7 kind of looks like a 1, but that's a 7. This is a good time to talk about order of operations, right? So order of operations says you need to do parentheses first. Don't see any, right? Then there's exponents, and there are some exponents in there, but they're not numeric. They're algebraic, so they don't quite count. Then the next pass, you do multiplication and division in the same pass. So we have multiplication here. If it helps, put parentheses. And we have division here. So if it helps you, put parentheses around what you need to do first. Then once you've simplified, then you subtract or add, whatever that sign may be. Okay? So in the same pass, we can do this parenthesis and this parenthesis. So let's do 52 divided by 4. Does it go in there evenly? Yes. How many times? 13, right? Then we have c to the 12th and c to the 2nd. You want to look for the larger exponent, which just so happens to be in that numerator, right? So we're going to put our base of c, and then order matters. So now we're going to go 12 minus 2 is 10. Then I'm just going to bring down that minus sign, and then simplify this set of parentheses. 2 times 4 is 8. And then both bases is c, so we know it's for sure going to be c, and we add the exponents 7 and 3, which is 10. Now, normally you'd stop here, but hopefully you notice that, oh, those are like terms, right? So we can combine them. So 13 minus 8 is 5, so this is 5c to the 10th. That's box number 7. Pull this up a little. See number 8. All right, there we go. Box number 8. You could start canceling and reducing if you want, but I'm going to multiply straight across first. But there is another way to do it. All right, so 10 times 2 is 20. Base of w, so definitely base of w. I'm going to write a 1 here if you want. Add them together, 1 plus 2 is 3. There's your new numerator. Denominator, we'll just rewrite it. Now we can simplify, right? So first, let's check the coefficients. Do they have a common factor? 4, right? So 20 divided by 4 is 5, and 24 divided by 4 is 6. Now, the numerator and the denominator both have a base of w, but which one has the larger exponent, numerator or denominator? Denominator, so I'm going to write the w in the denominator. And then order matters. So you want to do 8 minus 3, which is 5. Okay. Any questions on box number 8? Good? Awesome. Box number 9. We've got parentheses, so we're going to use that power rule from up top, and everything inside that parentheses needs to go to the 6th power, including the -3. So I'm going to write -3 to the 6th, a to the 2nd to the 6th, b to the 3rd to the 6th, minus the 2nd term. rewrite it. Okay? So let's simplify all these guys. So negative 3 to the 6th power is negative 3 times 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 negative 3. And you can type it in your calculator like that if you want. You can go negative 3 times negative 3 a bunch of times. But I'm going to show you a little shortcut. Okay? So on this calculator, and hopefully your parents got you one that has sine, cosine, and tangent on it, right? You're going to use the parenthesis, because that's how it is right there, right? You're going to use the negative button, type in negative 3, close that parentheses, and then you're going to use something called a caret, just a little arrow pointing up, and you can type any exponent. And then just hit equals, and that gets you 729. Unless you're super smart, you can do that in your head. All right, now let's simplify a to the 2nd to the 6th. So we multiply 2 times 6, and we get a to the 12th. Same thing with the b's. Multiply the 3 and the 6, we get 18. And again, we notice like terms. So we just subtract, and we get 704, a to the 12th, b to the 18th. Any questions on box number 9? All right, box number 10. Everything inside those parentheses goes to that power. That's the power rule, including the 9. So we have 81, base m, negative 4 times positive 2 is negative 8. Bring down that 1/3 m to the 6th. And then we're going to multiply 81 times 1/3. That's the same thing as dividing by what? 3. So 81 divided by 3 is 27. Add those exponents. Negative 8 plus 6 should get you negative 2 as the exponent. And you can't leave a negative exponent, so you need to move it to the denominator. So I'm going to write a fraction bar, put m, change it to positive 2. And what do I do with the 27? Does it stay in the numerator, or does it move to the denominator? What is the exponent on the 27? It's positive 1, right? We just don't normally write anything with a positive 1 exponent. We just assume it's there. So it's going to stay in the numerator. Okay. Last box. So I'm seeing a set of parentheses here. So I'm going to simplify that first. So I'm just going to rewrite the 4x to the 5th over x squared. You could simplify that first, but I'm not going to. And then I'm going to simplify this factor. So x to the 1st to the 3rd is x to the 3rd. Have to take the power rule to the denominator as well. So base of x, 2 times 3 is 6. Now I'm just going to multiply straight across on the numerators and straight across on the denominators. So 4x to the 5th times x to the 3rd is 4x to the what power? 8th. And then in the denominator, x to the 2nd times x to the 6th is what? X to the 8th as well. So we have x to the 8th in the numerator and in the denominator, so they cancel. And we're just left with 4.